Dear friends and colleagues, my name is Lev Bedrak and I am the director of Shendel Tech Company, Israel. For more than 15 years, our company is focused on dental implantology, including its technical, scientific, and clinical developments and applications. In the last 5 years, we have developed and implemented a number of methods of duplicating individually manufactured, prepared, milled, and polished abutments. Lately, we developed a device completely new for existing prosthetic systems. The device and the method of its application considered are patent pending. I will now briefly explain the advantages of this device and the principles behind its application in implant prosthetics. Many companies recognize the necessity of having abutment duplicates, and they offer various replicas for standard abutments. However, their use is possible only when abutments do not require additional individual processing. Yet, in case of multiple or total implantation for restoration with cemented structures, it is almost impossible to avoid individual preparation of each abutment due to complexity and specificity of many clinical scenarios. Of course, CAD/CAM technologies increase an opportunity of production of identical abutments specific for each patient. However, these technologies don't provide an ideal solution of all issues. Furthermore, not all specialists and not in all geographical regions can afford to purchase expensive scanners, including their software and maintenance cost. New development by Shendel Tech provides an opportunity to duplicate abutments without the use of costly technologies. Our technology is simple. It is affordable to any dentist and dental technician. It significantly simplifies laboratory and clinical stages of processes on implants, and most importantly, it is much healthier for the patient. The key of our invention is in a new shape, new principle of utilization, and additional application of analogs of dental implants. The shape of the majority of analogs used nowadays is determined by two principles. First, the necessity of reliable fixation of the analog within the body of the model, and second, at the same time, the possibility of relatively easy detachment of the analog from the body of the model for multiple usages. Analog LA, developed by Shendel Tech, has a novel concept of shape, and most importantly, a unique concept of application of analogs of dental implants. Part of the concept, an easy removal of analog from the model without destroying the model's integrity and subsequent return of the analog back to its place, has been developed before. However, what is completely new for removable analogs is the way of retaining high precision of their positioning within the body of the model, as well as providing their steady stability during the milling process of abutments fixed on analogs in model in the milling machine. This is achieved by two specific stabilizing elements. The first stabilizing element, retentive O-ring made of resilient material, is fixed in a specially created for it circumferential groove on the body of the analog. During casting of the stone model, the ring forms a recess in a stone, which preferably should be of type 4. Retentive ring and the groove in the stone are the parts of the first element, which provides stable fixation of the analog when it is inserted into his bed in the body of the model. The second element that provides stable fixation of the analog is a spherical attachment made as a lock. At the apex of the analog, there is a special spherical ledge. This ledge snaps into a corresponding nylon cap, which after casting of the stone model is extracted and placed back in case the need to strengthen the stabilization of the analog, for example during abutment milling. Besides, the analog has an outer secular platform with external pentagon. The pentagon, together with the existing inner hexagon, which serves as anti-rotation connective element, provides stable fixation and stability of future abutment duplicate using one of the methods of abutment duplication. But the main purpose of the external pentagon combined with the inner hexagon is to provide the only correct positioning of the abutment duplicate on the analog in case of its unforeseen detachment. Inside the analog, the usual inlet opening for the fixing screw has continuation along the entire analog body and ends with the outlet opening at the base of the spherical ledge on the analog apex. Such design is critical for improving the process of obtaining a duplicate, namely because it provides an air outlet when injecting the duplicate material and avoids the formation of air pockets. An ability of easy analog extraction from the model with its subsequent return into the model while maintaining high accuracy of the analog positioning significantly simplifies the process of preparing the abutment for milling, the following after the milling, grinding and polishing. It also facilitates the modeling phase of the base of the frame of the future prosthetic structure on the abutment and later many following stages. But most importantly, the design specific of analog LA and the ability to remove the analog connected to already prepared abutment, milled and polished, predetermine an easy, inexpensive and very accurate way of obtaining abutment duplicate fixed on analog LA according to the main method developed by Shendel-Tech. This, in turn, allows final installation of original abutments in the oral cavity without the need of their subsequent removal, and to use their duplicates, not original abutments, to continue the restoration. The merits and usefulness of analog LA and the methods of duplication with its application are difficult to overestimate. The restoration on the implants involves three parties: the dentist, dental technician, and of course the main figure, the patient. Health and time of each are extremely important. For dental technician, analog LA provides an opportunity to avoid countless manipulation during abutment preparation and later during the many stages of building the prosthetic structure. Usually, the dental technician has to constantly detach the abutment from the analog located in the model by unscrewing the fixing screw and attach it to a special holder in order to perform the necessary operation and then, in the same way, return the abutment to its place. Clearly, a simple removal of analog LA which the abutment is connected to from the model and placing it back significantly simplify the work of the laboratory stages. But the most importantly, this eliminates an excessive adverse mechanical influence on the abutment's connective elements. Now is the turn of the dentist and the patient. These two meet too often until the big project of restoration on implants is finally completed. These meetings, needed to fit the prosthetic structure during various stages of its fabrication, are accompanied by regular removal of healing caps or temporary abutments from the gum, which is unquestionably not the most pleasant and healthy procedure. Based on the above, an opportunity of using the analog LA and methods of duplication facilitates the work of the dentist and dental technician and, most importantly, helps to relieve the patient from the repeated unpleasant procedure. How is it done? After making individual abutments, the base of the frame of the future prosthetic structure is modeled on them using ash-free acrylic or composite materials. The temporary structure is also modeled on the abutments. Then abutments are duplicated. First, a standard screw that attaches the abutment to the analog is substituted by a screw with elongated body. The elongated body of the screw is essentially a funnel through which the material of the duplicate will be filled in. Then the space between the shoulder of the abutment and the edge of the outer round platform of the analog is filled with wax. To duplicate, we have developed a special box. The box consists of two parts, upper and lower. The lower part of the box contains sockets through which analogs with the ready attached abutments are inserted too. At the bottom of the lower part there are outlet holes through which spherical ledges on the apexes of the analog appear. The upper part of the box contains special terminals for each duplicated abutment. Terminals have through holes through which the elongated bodies of screw protrude when the upper part is placed on the lower part. A small quantity of material is applied to the abutments in order to avoid air pockets. Then the material is injected into the terminals and the upper part of the box is placed. After solidification of the silicon material, hooks and screws are unscrewed, the upper part of the box is removed along with the formed silicon casing. Abutments are removed and the upper part of the box is again placed back on the lower part of the box. Through the funnels formed in the silicon casing in places of the former location of mounting screws, self-curing composite material is injected until it starts to come out through the outlet openings in spherical edges of analogs. After hardening of the composite material, the upper part of the box is removed again. Analogs with abutment duplicates are removed from the sockets in the lower part of the box. Funnels are trimmed and analogs with duplicates are inserted into the model. This insertion will always be simple and precise. Extensive experience with analog LA and method of its use allows assessing the level of high identity and precision between the abutment originals and their duplicates. From the laboratory to the clinic goes a model with duplicates to which a base of the frame of the future prosthetic structure is mounted on, as well as temporary bridge and permanent abutments. For convenience, permanent abutments are mounted on a special matrix. After abutments are installed in the oral cavity and the base of the frame is successfully fitted, abutments can be permanently fixed, followed by mounting on the temporary bridge prosthesis. Finally, the model with duplicates and base of the frame can be sent to the laboratory to continue work. All subsequent fitting in the oral cavity, regardless how many, will not be accompanied by the removal of abutments. And so, the use of analog LA with techniques of abutment duplication is helpful for the patient, the dentist, and dental technician. If you are interested in our idea, please contact us. Thank you very much.